We are now turning to our next kai kōrero from ECOS to talk about diverse land use as the key to a sustainable transition. Please welcome to our kōrero today, Recloaking the Whenua, Mr. Sean Weaver.
Okay, kia ora koutou, ko Tomaniwi te maunga, ko Rewa te awa, ko Ngāti Kawalangi te waka, no o tautahi ahau, ko Sean Weaver taku ingoa. Sean Weaver, ECOS. I've been working in forest conservation with Indigenous peoples since the late 1980s, and in forest conservation, and from very early on in that work, it became very clear that if I couldn't finance the dream of forest conservation, then the dream simply wouldn't happen, or it would just stay a dream. And the key issue from the beginning has been, how does this landowner make a living doing forest conservation instead of what they were normally making a living doing on that land? So this work that I did was in both in the Pacific Islands, where I'm originally from, Fiji, which is where my mountain and river is, but also in Aotearoa and also in other Pacific Islands. And in order to finance this undertaking, you've either got to find grant money to do conservation, or you've got to get some sort of subsidy or some sort of commercial undertaking. Now, when carbon markets came along in the mid-2000s, after having worked in the sector for, by then, already well over a decade, probably about 15 years by that point, I immediately recognized the value of accessing private sector money to do this work, because there's a limited amount of public sector money and grant money to do this, as we've heard from previous speakers. And so what I did was set up ECOS essentially as turning conservation into a business, not because, well, for the main and only reason that I wanted to not be constrained by the absence of grant funding, that I wanted to be able to just do this work and not need any grants, not need Billion Trees funding, not need PGF funding, ideally. So the presentation I'll give you today will be talking about the economics of native reforestation in Aotearoa in the context of the emissions trading scheme. And I'll pull up a presentation and share my screen, and we'll go through it. So if you just hold the line, I'll find my screen and share it. And here we go. So, so the point of all of this work is to harness carbon markets for forest conservation. And across Te Rāwhiti and across many other parts of Aotearoa, there's a great need for significant areas of reforestation, permanent reforestation. I mean, Hawke's Bay, for example, alone needs about 200 to 300,000 hectares of reforestation in order to cope better with extreme weather events that are heading down the pipeline. We have challenges in many, many parts of the country, including the Gisborne district as well. The challenge at that scale is, it needs a lot of money, and yet at that scale, there's absolutely not enough grant funding for the task. In addition, we can rely to some extent on natural regeneration, but if we do really want to respond to a climate emergency and build climate resilient landscapes with permanent forests on them that can cope with especially the likely increase in intensity of ex-tropical cyclones, we're going to need to do some active planting and not just rely on regeneration alone, although they complement each other quite well. The solution potentially is that, in fact, there are enough funds in the private sector for this job. The challenge, though, is that to get access to that money, you've got to generate a return, a financial return. And this is where we come up against some barriers, and the barriers include the fact that carbon economics of native reforestation are very challenging, which we've heard from previous speakers and which we at ECOS know intimately through practice. So just looking at from a business lens, if we are going to do this work with private capital, it's useful to think about it through looking at it through a business lens. And so the way that we break it down is into three forms of cost for forest conservation. If you're doing a carbon project, say, you've got your capital expenditure where you build your carbon credit factory, which is, in other words, your forest, and you register your forest and pass through all of the challenges that we just heard in the last presentation. But we establish our forest. But then you've got to operate and manage that forest. And a key element of that is pest and weed control, and I'll come back to that. And the other part of the puzzle is the opportunity cost, which is the benefits that landowners have to give up in order to do it. So let's have a look at the capital expenditure involved. We need to develop the project, develop the business plan essentially for the project, so we know exactly who's doing what, where, how much everything is going to cost, what the revenues are going to be. We need to establish the eligibility of the project under the emissions trading scheme. And we have to have a very detailed management plan to get the project to the point where it's investment ready, where an investor can come in and say, yeah, I can understand this project. I know what's happening. I can see the costs and the benefits. I can see who's going to do what. And that takes us to also to implementation readiness, where you can actually start spending money on ordering seedlings and planting them. The other element of capital expenditure is the actual establishment of your project. You've got to purchase seedlings, you've got to prepare your land, you've got to do some pest control sometimes to make sure the rabbits don't eat your capital expenditure. Then you've got to put the plants in the ground. You do some survival monitoring and blanking, which is replacing stems that died in the first summer, some releasing, weeding, and post-planting pest control and a bit of management. Then you've got your operating expenditures, and fundamentally this is conservation management, because when we establish native forests, we create a habitat for all sorts of wild animals that are going to compromise the conservation value of this area. So one needs to allocate funds ongoing into pest and weed control, but there's also things like tracks and fencing and managing teams and insurance and a range of different things. And from a carbon project perspective, we also have to measure our carbon and report it, verify it, so that we can issue carbon credits and then of course monetize them. The opportunity cost is the other part of the puzzle, when of course landowners need to be able to make a living off their land, and that's why land is owned, so that it's an asset. And if we want to work with the middle of the bell curve, the bulk of the population in the rural landscape, we're going to need to find a way for farmers, landowners, to actually afford to give up beef and lamb revenue on that land in order to reforest it. On the margins, at a smaller scale, we don't need to do this because there are many people already who are retiring paddocks for conservation and not needing any compensatory payments for that. But there are many, many people who do need that because simply they're making a living off this land. And to do conservation, the Forest Carbon Project needs to at least compete with the beef and lamb revenue they were otherwise gaining, so that they can not only cover the costs of planting and managing the conservation project, but they also need to feed their kids and send the kids to school and all the usual things that people spend money on with a livelihood. Thing is, from a commercial perspective, if we cannot fund those things, capital expenditure, operational expenditure, and opportunity cost, if we can't fund that through the revenue gained from the sale of carbon credits, then the project simply will not happen because you won't be able to secure any investment, and we'll be back to the problem of having to try to use grant funding to do this work. So what's required for private investment to come along? Well, the key rule of thumb is that we need to generate a financial return. So somebody who gives us money, we need to give that money back with some interest. Carbon trading can provide revenue. The key question is, will carbon trading revenue be enough to cover all of your costs In other words, is the project going to break even, or is it going to run at a loss? And of course, to generate a return, it has to break even, in fact, turn a profit, so that profit, what's left over after all your costs, is able to be spent on paying back your debt. The graph there shows you different types of forest types, if you like, and the carbon credit production rate from them. This is just using the lookup table data. So Indigenous, you can see there is the slower producer, which we've heard in the last few presentations. Pines have a higher rate of carbon sequestrations, and exotic hardwoods, things like, well, this is modelled on a eucalypt model. You know, their carbon credit production rates are a bit higher. Let's have a look at a case study just to see what this might look like through a commercial lens. And the first piece of this would be to look at, well, what about a natural regeneration project? Can that project succeed commercially in theory and in practice? So what we've got here is a carbon credit production rate from a naturally regenerating forest that's eligible to register in the ETS. And I think I was assuming that the forest established in 2010, which is why you've got a carbon credit production rate starting already at that 1,000 tonnes at the beginning. And then we're looking at modelling the carbon price starting at $50 and then rising at different rates per year on average across a 50-year cash flow. So the three rates that we've modelled is starting at $50 and rising at $1.50 every year on average, CP1. CP2 starting at $50 and rising at $4.75 a year, and CP3 starting at $50 and rising at $8 a year. And the graph at the bottom left is showing you what the carbon price has done over the last year. You can see it's risen very steeply from hovering around the $25 price cap that the government imposed, and now shooting up to the $50 mark and overshooting that $50 mark. The internal rate of return is an indicator of profitability of a project. And with a natural regeneration project, because there's very little capital involved, because nature did the planting for free, there is some capital expenditure, in other words, costs for project development. So there are costs involved in doing vegetation age assessments, doing the mapping, doing the management plan, all of the stuff that you need to do to register a project. There's still a cost, but because you didn't have to fund all of the purchase of the seedlings and the planting of those seedlings and things, your capital costs are relatively low. And as a result, you can get reasonably high internal rates of return. So if the carbon price were to start at $50 and rise at $1.50 every year at CP1, then the internal rate of return is up around 35%. And then it goes north of that if the carbon price rises at a higher rate than $1.50. The net present value is another indicator of profitability of a project. And we've got the net present value of this natural regeneration project, 100 hectares at the three different carbon prices, and compared that with an opportunity cost of leasing out that same area of land for grazing based on a placeholder lease value of 3% of the land value per year. Lease value. And what we can see for natural regeneration is that the three histograms on the left are all bigger than the one on the right. In other words, the carbon project is more profitable than leasing the land out for the same land out for grazing, assuming leasing it out at 3% of the land value. There are some barriers, however, and we've heard about those in the last couple of presentations. NZETS eligibility is hard with natural regeneration. You've got to do a lot of detailed mapping, typically have to do vegetation age assessments, which is on the ground sampling, and that can get quite costly. There's also the timing of emissions trading scheme application process, and it can take very many months and significant costs, and there's lots of uncertainty. But anyway, it can be done, and it is being done, and we've got some really good examples around the country and in your region. The work that Anne Salmond is doing at Waikato is a fantastic example of a natural regeneration project that also includes some infill planting. So yeah, fantastic example. Now, this is also now going to look at what if it was not natural regeneration, but we had to plant the forest ourselves, buying the seedlings and planting them with human effort, human labour. So we've got the same carbon price scenarios. We're modelling the planting of natives. The scenarios there: native afforestation up the top right, native afforestation at 8,000 stems a hectare, native afforestation at 4,000 stems a hectare, native afforestation at 2,000 stems a hectare, then 1,000. And then the bottom two are a blend of natives and exotics, where 80% of the area is planted in natives and 20% is planted in exotics. And then the final one at the bottom, where 20% of the area is planted in natives and 80% is planted in exotics, just to see what the economics look like. So let's have a look. If we look at the capital expenditure for that 100 hectares of project, then the planting natives at a high density is essentially very expensive, the most expensive option. And as you can see, the capital costs go down as you reduce the planting density of natives, and then even when you include exotics in the mix. And I'll talk about the exotics and how we would manage them in this transition to natives in a moment. But for now, we're just looking at the costs. So if we then to look at cost per hectare, which is often a bit more meaningful, we can see there that native afforestation at 8,000 stems a hectare, you're looking at over $50,000 a hectare to get that forest established. Whereas if you were to plant natives at a much lower density, like 1,000 stems a hectare, which is well enough to, that's a high enough density to register the project in the emissions trading scheme, then you're down below $10,000 a hectare. Similar sort of prices when it's a blend of natives and exotics. But if there's more exotics than natives, the costs will come down even more. Then we're looking at the internal rates of return, so indicators of profitability of these projects. For native afforestation at high stem densities, it's essentially not profitable. And it starts to become profitable for all different carbon price scenarios when native afforestation is done at 1,000 stems a hectare. You can see the three different histograms for the three different carbon price scenarios are all above zero. And then it gets better when you introduce exotics into the equation. Similarly, if you look at the net present value, you've got projects that are all in the negative until you get into native afforestation at a low stem density and then into a mix of natives and exotics. So to picture this, and this is our approach, is when we're asked by a landowner to develop a native forest carbon project for them, we say, okay, that's fine, but what internal rate of return is required by the investor? The investor might be the landowner or it might be a capital provider. Or what interest rate essentially they want on their money, and just bear in mind internal rate of return is not the same as the interest rate. But let's say we have a high density native afforestation at 8,000 stems a hectare. We've got a very negative internal rate of return, in which case we don't get any money for capital investment. If we were to do medium density natives, then our negative internal rate of return is smaller, but it's still negative. Low density, for example, 1,000 stems a hectare, now we're getting a positive internal rate of return indication. But it still may not be enough to deliver even quite a low percentage interest rate on money invested. Like, for example, a 2% return on investment would fail under an internal rate of return of 2%. But as soon as we introduce, say, an exotic woodlot, and it doesn't have to be adjacent to the natives, but somewhere in the project area, then we are able to push the internal rate of return up. And if the exotic woodlot gets a bit bigger, it goes up even more, and it can get us to the point where the project is now fundable without any grant funding, where we can be independent of hoping billion trees funding comes back, and independent of any grant funding at all. And bearing in mind, if we want to do this at scale, we really do need to ideally become as independent as possible from grant funding, simply because there's just not enough to do the reforestation at the scale that certainly ECOS's ambition is, in terms of tens of thousands and hundreds of thousands of hectares. So looking at this exotic woodlot, I mean, what's its purpose? Well, certainly for us, the purpose, there's twofold purpose. One is to fund the natives, and the second purpose is to fund the natives. That's the only reason why we have them there. As indicated, they don't need to be in exactly the same place as the native reforestation. They could be in a separate part of the land. And if it were an aggregated project across the whole region, you could have a whole area that is an exotic woodlot that's able to be used to drive the economics of native reforestation elsewhere. What exotics do you use? Well, that's also up to local ecological knowledge and local forestry knowledge, essentially a right tree, right place scenario. Then what we would do is transition the exotic forest to a native forest. And the way that we'd do that for that woodlot is basically thin it after about 12 years, and then in year 15, take 10% out and then replace it with natives. And so you've got your blue for exotics and green for natives. So by year 20, you've got at least 10% is natives. And then by year 30, you've got even more native areas that have now got young native forest on them as the exotic forests around them get older. By year 40, you've got even more. By year 50, even more. And by year 60, you don't have any exotic forest left. So for that exotic portion of the project, you can also transition that fully to natives through time if we're patient. And again, the purpose of having the exotics there is to fund the whole exercise. Got some project examples to share with you. We're doing this kind of work already. We've been working with investors and landowners over the last couple of years doing exactly this. So I'll show you an example of a project in Southland where the purpose is to create a native forest in this riparian area. And what we've got is areas of native only reforestation in blue, and also in the very top right-hand corner, this area D4A, that's also native only. These other areas are native only plantings in more wet areas, and then exotics are going in these reddish areas, and then will be transitioned to natives in the through time, as I've described before. This is what the site looked like before it was planted. You can see the areas that we're planting in native only here, like the wetland D1, D4.1, and various other wetland areas throughout the site that are being replanted in natives only. For the native plantings, that includes community planting days, and for larger scale native plantings, then we use contractors to complement that. An example of a Northland project where the landowner didn't want any exotics in the, as a Maori landowner, they didn't want any exotics in the mix. So we had to put our thinking cap on and be a bit creative and figure out how to deliver on that. We're working with an investor who's willing to provide capital at 2% across a 25-year maturity. And we've got an opportunity to have a mix of native active reforestation planting as well as some native regeneration. So this project has 10 hectares of native regeneration in it. And the regional council here has also provided a grant to supplement the project. So let's have a look at the details here. We've got 10 hectares of natural regeneration. The native reforestation piece, where people are doing the planting, is 75 hectares. The co-financing grant from the regional council is worth 120,000. The private investment from the investor is 600,000. The interest rate on that money is 2%, and the returns start to get paid back starting in year 6, and the investment maturity date is 25 years. Key thing here, though, is that the key success dependencies for this project, because it didn't have any exotics, it needed to have some natural regeneration, which gave us carbon credit cash flows without much capital spend. And also the co-financing grant gave the project a lift. Also, we had a low interest rate. Now, if we change any of those things, if I put the interest rate up to 3%, the project would have failed. If we reduced the co-financing grant from 120,000 maybe down to 100,000, then the project failed. If we reduced the natural regeneration from 10 hectares to 5 hectares, the project failed. So getting this project over the line required toggling the different project factors to make it work in the end. The take-home message, to succeed at scale in looking after the whenua at scale, then we need money at scale. To source money at scale, we need to deliver a financial return, because there simply isn't enough free money around, grant money, to do the job at the scale that we're looking at. And when I'm talking about the scale of funding, for 100,000 hectares of reforestation would cost, I mean, you'd need about $1 billion of capital for that, maybe more, maybe $1.5 billion. And you'd need to have a return on that investment. So that's the sort of scale that we're talking about. And delivering a financial return is going to require either a co-financing grant, an exotic woodlot element, a native regeneration piece, and or a low interest rate on investment. Here's an example of native forest in Golden Bay in Mohua, top of the south, where this is a native forest understory, and there's an exotic forest element here that helped make all of this happen. And this is 40 years after the project was established. So it's, I guess, living proof that establishing native forest in the context of a blend of natives and exotics can work. Thank you very much. Kia ora koutou. Happy to take questions later on.
Kia ora, thanks very much, Sean Weaver there, e te whānau.